So if that is our definition for diversity in STEM, why is it important? What is the value of diversity in STEM and STEM education? Why are there programs to broaden participation in STEM and STEM education? Beyond equitable representation, increasing the number of underrepresented groups working in STEM is strategically important. First, the practical implications of demographic shifts in the United States highlight the need for increased diversity. Projections of population growth suggest underrepresented minorities will outnumber white men in the next 2 decades. Therefore, in order to maintain a viable STEM workforce, we need to broaden participation of underrepresented groups in STEM. Moreover, individuals with backgrounds that differ markedly from those who are already represented in STEM can bring their experiences to the table that are very important for the work that is being done by scientists and engineers. For example, we can think about pharmaceuticals and developing pharmaceuticals for different diseases, medical outreach practices tailored to underserved populations. Having broadened representation in STEM is important to meet the needs of folks in these areas. Secondly, the scientific and engineering challenges of the 21st century require high-performing diverse groups. Research suggests that diverse groups come up with more and more creative problems. Therefore, as the world becomes more global, as we need to work together to address scientific and engineering challenges, we will need to have more diverse groups working together to solve these problems. So let's explore this idea a little bit. First, I would like to explore it in the abstract using a children's book called Fish is Fish by Leo Lionni. This book is referred to in the book How People Learn, and I'd like to use it a little bit differently than the way they use it in How People Learn. The book describes the relationship between a frog and a fish. The frog and the fish live in a pond together, and one day the frog decides to leave the pond and go explore the world. The frog goes out into the world and sees many things like people and birds and cows. The frog returns to the pond and starts to tell fish all about the things that he has seen out in the world. The illustrations in the book show how the fish envisions all the things the frog is describing, the things that the fish has never seen before. So when the frog describes a bird, the fish envisions a fish with wings. When the frog describes people, the fish envisions an upright standing fish walking on feet. What this demonstrates is that we all have different perspectives, different ways of thinking, and different ways of viewing the world. These different perspectives have value. If the fish and the frog had completed the diversity game together, they would have come up with more terms, more characteristics for the game. We expect groups that have different perspectives working together to come up with different ideas. Beyond things like the diversity game, this has implications in the real world, meaningful implications in terms of solving problems facing our world. As James Surowiecki puts it, groups that are too much alike find it harder to keep learning because each member is bringing less and less new information to the table. And another quote from Scott Page, the author of The Difference, he states, "The problems we face in the world are very complicated. Any one of us can get stuck. If we're in an organization where everyone thinks in the same way, everyone will get stuck in the same place. But if we have people with diverse tools, they'll get stuck in different places. One person can do their best, and then someone else can come in and improve on it." This quote is grounded in research that Scott Page has performed using computer modeling. In his modeling framework, diverse groups of problem-solving agents outperformed homogeneous, high-ability groups of problem solvers. In his book, The Difference, he applies this research to the real world, including to schools and groups of people working together, such as those in medicine and science. He describes the benefits of functional diversity, these differences in the way people approach problems, the talents that different folks bring to a given situation. Groups are better if the individuals have functional diversity. But in real life situations, we don't always have a measurement for functional diversity. You can't tell how a person will approach a problem. It is not something that is easily articulated or categorized. So instead, we use identity diversity as a proxy for functional diversity. You can look around the room and see the characteristics associated with identity diversity. Proponents of diversity contend that identity diversity results in functional diversity. That is, if we have a group of individuals who are of different ethnicities, different genders, different ages, sexualities, religions, it is likely that they will think about things differently, that they will approach problems differently. These types of group will therefore be more creative and more productive. Beyond Scott Page's work, there are many examples from the literature that support the contention that diverse cooperative groups could enhance learning and benefit science. Research has shown that heterogeneous groups devise more and more creative solutions to problems than homogeneous groups. So in this type of research, you have small groups in controlled experiments that are given a challenge, that are given a problem to solve. And when those groups are heterogeneous, based on identity diversity, those groups come up with more and more creative solutions. In other experiments, controlled experiments, researchers have shown that expression of minority viewpoints leads to divergent thinking. If you have a group of people and you have a minority viewpoint being expressed about a topic, this will lead the group to broaden their thinking, to expand their thinking. However, if you have a group where no minority viewpoint is expressed, this tends to lead to convergent thinking. It is important in science to have divergent thinking, to have people that think outside of the box in order to solve problems in science and in engineering. In other studies, groups have examined the effectiveness of different types of groups, including those ranging from theater groups to those in academic science. And what these studies have shown is that the most effective groups include members with diverse experiences and backgrounds. And finally, research has also been done to show that multicultural experiences are positively correlated with creative performances such as insight learning and idea generation. These are the type of things that are very important for science and engineering, things like insight learning and idea generation. So beyond talking about how diverse groups of individuals work together to solve problems, we also want to think about the value of diversity in STEM and STEM education specifically. And studies have shown that diversity enhances college and the learning experience. A very large study done by Alexander Austin and his colleagues examined what was important in college. They looked at 25,000 students from 200 different universities and followed them for 4 years. They examined student outcomes, things like self-reported gains in learning, self-reported gains in knowledge, problem-solving ability, student retention, and student performance on standardized tests for graduate and professional school. And what they found, shown here on this slide, are all of the things that are associated with positive outcomes. And if we look at this, there are several associated with diversity. Discussing racial and ethnic issues with other students. This is related with positive outcomes. Socializing with diverse students. Institutional emphasis on diversity. These things are related with positive outcomes for students. Research on the role of diversity and the benefits of diversity in STEM education continue to show that this is an important part of improving the student experience and improving student learning.